The swivel hook control is used to rotate the crane's hook. By using the left and right buttons of the swivel hook control, the operator can swivel the load hook so that a load can be rotated to the left or the right. Many overhead cranes are floor controlled. That is, their controls are mounted on a pendant. A pendant is a control box suspended from a cable that's attached to the electrical system of the bridge. When a pendant control is used, the crane operator walks along with the load as the trolley or the bridge travels. One thing to keep in mind if you're using a pendant control is to not activate two buttons for a single feature simultaneously. For example, attempting to move the bridge in the forward and reverse directions at the same time could damage the crane's control mechanism. Nearly all mobile cranes, as well as some stationary cranes, are equipped with some type of boom. A boom supports the lifting tackle and can be swung, tilted, and in some cases extended and retracted to a desired position. Some boom cranes have telescoping booms, which are controlled by hydraulic cylinders powered by pumps. Others have lattice booms, which are controlled by cables that are driven by winches. But regardless of how a boom crane is configured, its mobility and versatility makes it suitable for a wide variety of rigging jobs. Since we can't look at every type of boom crane that's available, we'll focus instead on the basic features of one type that's commonly used to move heavy loads, a crawler crane. Because of its wide crawler tracks, a crawler crane is very stable on soft or rough terrain. As with most crawler cranes, this one has a lattice-type main boom. The base of the main boom is hinged to the superstructure of the crane. On this crane, the opposite end, or top, of the main boom has an extension called a luffing jib. The luffing jib provides additional boom length and supports the lifting tackle. Extending downward from the ends of the main boom and the luffing jib are fixed-length wire ropes called pendant lines. The jib pendant lines are supported at the top of the main boom by a pair of structures called front and rear struts. From the top of the boom, the main boom pendant lines and the jib pendant lines connect to a movable support structure called a mast. The mast also provides a connection point for the boom hoist lines. The boom hoist lines are threaded or reeved around sheaves and drums on a structural frame called a gantry. The network of hoist lines and support lines makes it possible to raise and lower the main boom, the luffing jib, and the load. Devices called boom stops limit the angle of the main boom at its highest recommended position. A device with a similar function, called a jib backstop, prevents the luffing jib from toppling over backward. Counterweights mounted onto the back of the crane supplement the crane's weight and offset the weight of the load. An operator's cab houses the crane's controls. Many modern cranes have a computer that provides valuable information about operating conditions. For example, when this crane is started up, its computer goes through a system test. It prompts the operator to respond to various safety and operating messages in a startup checklist. Once the startup checks are complete, the operator enters information into the computer about the crane's configuration. The computer then uses that data to calculate and display information, such as the amount of weight on the load line, the operating radius of the crane, the luffing jib offset angle, and the maximum lifting capacity that's available under the current conditions. This is the crane's swing control. After releasing the swing brake, the operator can move the swing control forward or backward to move the revolving part of the crane and the boom to the left or the right. This is the crane's main boom tilt control, or simply the main boom control. By moving this control forward or backward, the operator can change the angle of the main boom, that is, lower or raise the top of the boom. Here's the crane's main hoist control. It's located beside an auxiliary hoist control, which isn't being used in this crane. By moving the main hoist control forward or backward, the operator can lower or raise the crane's main hoist line. This is the crane's jib tilt control. By moving this control lever forward or backward, the operator can change the angle of the luffing jib, that is, lower or raise the end of the jib. Cranes typically have foot pedals to help control basic operating functions. For example, this crane has a brake pedal for the main hoist and a brake pedal for the auxiliary hoist. Both hoists have automatic braking systems as well. This crane also has pedals to control the left and right crawler tracks, and a throttle control pedal for the engine. By law, all cranes must undergo safety inspections. The frequency and thoroughness of these inspections depend on factors such as how the crane is used and how much it's used. Inspection guidelines are based on federal regulations issued by the Occupational Safety and Health Administration, or OSHA. Guidelines that apply to overhead cranes and gantry cranes are collected in one category, and those that apply to crawler cranes, locomotive cranes, and truck-mounted cranes are collected in another category. The procedures outlined in each category are further divided by the type of inspection that's required. For instance, inspection procedures for cranes in regular service are divided into two basic groups: frequent inspections, which are general inspections typically done by the crane operator at least once a day, and periodic inspections, which are thorough inspections commonly done by an expert at least once a year. An overhead crane should undergo a general inspection at least once a day, or ideally before each shift. Much of this inspection involves visually checking the crane's major components. For example, the bridge, trolley, and hoist mechanism should be checked for obvious wear and damage. Not all of the components of an overhead crane are clearly visible from the ground. Some must be inspected from up near the operator's cab. Among these components are the reels for the wire rope and electrical lines, as well as the lines and connectors that make up the lifting tackle. All these components should be visually inspected for wear, damage, and improper reeving. It's also important to check the operating controls in the cab to make sure that they're functioning properly. Only after all these basic checks have been completed should the crane be placed in service. The frequent inspection of a crawler crane is basically a visual check of all the crane's major structures and systems. For example, before this crawler crane is used, the operator does a walk-around inspection to make sure that the major components, such as the crawler tracks and all the safety guards and plates, are in good condition. He also checks for any broken or loose connectors around the crane's superstructure. Because of its importance, the operator keeps a close eye on the crane's hydraulic system during the inspection. Part of checking the hydraulic system involves making sure that the fluid level is normal. Another part involves checking hydraulic lines for leaks or other problems. It's also important to inspect the crane's support structures and hoisting components, including the wire rope, the reels and sheaves, and any connectors that may be present. The operator completes the inspection by checking the crane's computer and operating controls to make sure that they are working properly. In this topic, we examined heavy lifting hardware and different types of bridge cranes and boom cranes. We also looked at some basic crane inspection checks. Now try some practice questions on this material. Before you can safely perform a lift, you have to be able to read and interpret the load capacity charts for the crane you're using. Capacity charts explain critical measurements and warnings that must be considered when lifting capacities are calculated. Crane manufacturers provide individual capacity charts for each machine they produce. These charts can't be interchanged because similar cranes can still vary a great deal depending on how they're equipped. To prevent accidents and equipment damage, the proper capacity charts must be used, and all the requirements listed on the charts must be met. The chart heading lists basic information about the crane and its equipment. On this chart, the information includes the manufacturer's name and the model of the crane. It also includes the boom number and the style of the boom point, or top, the length of the crawler tracks, and the weight of the counterweight. The information in the chart heading should be compared with the equipment on the crane to make sure that the chart and the crane match. The lifting capacities section of the chart is actually two parts, one in text form and the other one in the form of tables. The text part helps clarify some of the capacity information that appears in the tables. The tables, which are arranged in columns and subdivided based on the boom length, provide the actual capacity values for the crane under different equipment configurations and operating conditions. For example, this part of the table shows capacity information for a main boom length of 70 feet. The columns provide information about the operating radius of the crane in feet, the boom angle in degrees, the boom point elevation in feet, the crane's capacity in pounds with the crawlers retracted, and the crane's capacity with the crawlers extended. Capacities listed in the shaded area are based on the strength of the structural parts of the machine. Capacities followed by the letter B indicate boom positions in which there's too little backward stability, that is, too little resistance to overturning backward. Using this line from the chart, we can see that with an operating radius of 30 feet, a boom angle of just over 68 degrees, and a boom point elevation of 72 feet, the crane has a lifting capacity with the crawlers retracted of 142,800 pounds, or with the crawlers extended of 165,400 pounds.